Thank you all for coming. Welcome to this talk on Java 9 modules. Let me take my glasses off. Right, so these are some of the topics we're going to be covering today. It's an introduction to the topic. So yeah, we'll be going from the ground up as to what modules are and the syntax that has been added to Java 9 to support them, and some of my views on how it works out. So modules, this is Project Jigsaw, is what it was known as, and the Jigsaw mailing list does still exist at OpenJDK. So officially, it's the JPMS, the Java Platform Module System. So it's a bit weird when you say JPMS modules, because you're sort of saying modules twice, but that's sort of the name of the system. Okay, it was the main feature of Java 9, and it was obviously released September last year now. So it was originally targeted Java 7, which means it was first JSR back in 2005, so 12 years to complete. That's the thing about changing Java, it's hard, and it does take a long time. So intention really to scale Java down to smaller devices. Java's become over time a very big amount of code. It would be nice if you could have a smaller subset of that code so you could run it on smaller devices in a nice, effective way. And if you reduce the size of the APIs and better control some of those packages, then you can improve security and maintainability. And security has become increasingly a problem. There's been quite a few reports over time of Java being a security problem. So part of that was a key goal here. If you can again reduce the scale of the API, and lock down particular modules, that gives the opportunity for Hotspot to make better decisions on performance. If it knows for more certainly the method is not going to be overridden later, then it's able to actually make a decision on that. And in theory, it's easier for you to construct your libraries and applications. So Java 8 had 210 packages. We forget how big it is sometimes. Yeah. Hands up if you use Colebourne. That's nobody. Anybody use AWT? 2, 3 maybe. So basically, the whole point is that not everything is used by everybody. It's reached the point at which, just like when we depend on multiple different jar files from different open source projects, it'd be nice to depend on just parts of the JDK. So we split up the JDK, and you get modules. So Java 9 has 26 modules. So the core module is called Javadoc base, and that includes all the basic bits of Java you might expect. So it includes Java lang, IO, math, security, text, time. So you can almost think of Javadoc base as being the new core bit of Java. It's the new Java with lots of extra things available as other modules, but Javadoc base is now the JDK in some ways. If you want logging, Java util logging, you've got to put in an extra module. If you want SQL, you put in an extra module. Same for XML or desktop. Seems good. So how do you express that? Well, if you go and look at the Javadoc for Java 9, you will see that the first thing you get to is a list of modules. So you have to choose which module to look at first before you can go and find the actual classes and packages. And in Java 9, there were 7 modules deprecated for removal. So if you wanted Colebourne, it was deprecated. Or XML-WS deprecated. Activation deprecated. Basically, that is mass deletion from the JDK. Now, in Java 9, they're just not there by default. They're deprecated, but they're not there by default. In Java 11, they're not there at all. They have gone. So in September this year, they have gone. And there is the module graph. And I've carefully marked, cross, 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 those have gone. Now, given that Java 11 is the next long-term support release of Java, many of you will be upgrading from Java 8 to Java 11. And when you do so, you might be surprised, if you haven't been paying attention, just how much has gone. So be aware of that. Hopefully, since none of you are using Colebourne, hopefully that won't be too bad for you. Lots of links for those who want to look at the slides later. Okay, so obviously, we've all been using the class path for many years. Class is loaded on demand. You have the class path, and the class path is the thing which specifies where you find bytecode. So you list out all the various jar files and directories where you're going to find that. And then the boot class path loads up a single jar file with all the JDK classes in it, rt.jar. And then you have the extension class path, which you may never have heard of, which contains standard extensions. Let's not worry about that too much. And then there's a user class path, which loads all the user code. So each class is always loaded by one class loader. And in order to work, typically, class loaders delegate to their parents. So you have one class loader for each of those three class paths, one for the boot class path, one for the extension class path, one for the user class path. And they delegate to each other. So to find a class, you have to start searching through these different class loaders. So you have to find myfoo.class, you have to look in the application class loader, which will first look in the extension class loader, which will then look in the boot class loader, not find it, drop back to the extension, not find it, drop back to the application, and then find it. That's quite a long, drawn-out process for finding a class. Not ideal. And it allows other questions to arise. What if the same class occurs twice on the class path? What if it's not found? Does order matter? Can the same class be loaded by two different class loaders? So various questions arise as a result of the design of the class path. Once we've got them all there, pretty much it's also the case that anything can call anything. So once we've got a.class and b.class.c.class, and if these came from three completely different jar files, that doesn't matter at runtime. They can all call each other and they can all see each other. All that nice structure of jar files which he created kind of just gets thrown away on the class path. At runtime, it's just an amorphous mass of classes. So the first key requirement was to have this reliable configuration where we replace the class path with a graph of dependencies. And that graph of dependencies is just like the graph of dependencies you see if you've got a Maven tree of dependencies. That way you know, when you start your application, what do you need? It means when the application starts, you can check and do some sanity. Is everything there? Are there no duplicates? And maybe, in the future, you could do some optimizations. But packages currently, in Java 8, packages is all we've got. We have many packages in our projects and in our dependencies, but often we have to make things public that we didn't really want to be public. I'm sure you've probably written a package that has impl in the name or internal in the name or please don't call this, I beg you. There's a missing language feature there, right? I mean, that's the Jackson set of packages. .impl, .impl, .impl. You shouldn't really be able to call any classes in there at all. They were obviously intended for the purposes of the Jackson writers, not for you to use. Similarly, you're not supposed to call code in sun.misc or jdk.internal, but you always could. And that's a security hole, because it doesn't allow the JDK designers to lock down their internals. So the second requirement was strong encapsulation, such that a module can basically declare which packages it's exposing to other modules. And therefore, it can hide certain packages that are not exposed. So, what's our module? Well, something with a name, consists of a set of packages. Obviously, they contain all your classes and interfaces, and some metadata to describe the module. That metadata is modulinfo.class, as we will see. You will typically package this as a jar file, the same way as you've always packaged it as a jar file. Nothing terribly new there. But one of the key take-home things from this talk is it's enforced by the JVM. So the JVM knows about modules in exactly the same way as it knows the difference between public scope and package scope and private scope. Because it understands what a module is, the JVM can enforce those boundaries. And even if you try and do something clever to work around The JVM is the one holding the reins here, and the JVM is the one that can enforce things. So here's my example jar file for the talk, opengammautil.jar, containing 3 packages, opengammautil, math, and impl. Now, unsurprisingly, I don't want people to see impl. Now, as it stands today, that's just a jar file on the class path. Anybody can call anything. So, jar file on the class path, you can use any public type or method from that impl package. I'm telling you, you shouldn't. I've got some nice Javadoc to say you shouldn't, but you can. So we pop on a module info.class within that same jar file, and now it is a module. Now, at the bottom, if you're lucky enough to be able to see the screen clearly, is the module.java file that produces the module info.class file. So in there, we're basically saying module and our module name, opengammautil, and we're exporting 2 packages, the opengammautil package and the util math package. We are not exporting, we are not listing, we are not mentioning the import package. And by not mentioning it, it is encapsulated, it is hidden. That non-export packages can't be seen. So how do we enforce this? So that old class path thing that you remember, well, it's now got a parallel. There's now a module path. So in order to be a module, it has to have module info.class in the jar file, and the rules that module info.class contains, they're enforced if the jar file is on the module path. Those rules are not enforced if that jar file is on the class path. To my understanding, there is no EE app server today that understands module path. So all those module info.class rules that you spent ages writing, they will not be enforced if you're running an app server. Just saying. JVM determines and validates the module path. So yeah, when it starts up, it's going to read the module path, it's going to check the module path, and it's basically going to draw up a module graph as a result of that. And there are advanced use cases using a classical module layer, but we're not going to go into the details of that. What we can say is that the JDK itself always runs in module mode. So all the JDK classes with their module info.classes, they are enforced. That is actually enforced. If you're on the class path, you can see the whole of the JDK. But if you've got a module info.class, you only see java.base. You have to specifically specify if you want more than java.base. And the implications of all of this is there's no more rt.jar, which can affect certain tools who've made use of that fact. Now, in fact, the JDK itself is not packaged as jar files, it's packaged as JMod files, and that's because they contain native code, C code for talking to the operating system and so on. Ignore JMod files. It's just a format that is used by the JDK effectively. There isn't a boot class path or an extension class path in the same way as before. So a bit more drill down into that module info.java file. So we're essentially asking ourselves 2 basic questions. What things does our module depend on, and what packages does it export? Now, since we always depend on java.base, you don't really need to specify that, and nobody ever does. So this is the file. So we've got our module name at the top. We're listing the modules that we depend on. So in this case, we require comgoogle.common. Now that's Google Guava. We also require all Joe beans. And we export, in this case, opengammautil. So those are the 2 elements that we have to discuss as part of our module info.java file. Okay, so having defined that, that gives us our module graph. So we have opengammautil at the top, and we required 2 other modules. Great. So next one down, we obviously need to say, well, what does org.joda_beans look like? Org.joda_beans depends on org.joda_convert. So we specify that it requires org.joda_convert, and it exports org.joda_beans. Great, we know all those rules already, we've just learned them. So we can add that to our module graph. Hooray. But it turns out that Joda_beans exposes types in its public API from Joda_convert. So it's not possible to use Joda_beans without being able to see and use the types from Joda_convert. So in order to express this, we use requires transitive. So what we're basically saying here is, not only do I depend on org.joda_convert, but anybody who uses me must also use Joda_convert. So if you include any types from another module, you probably want that to be all requires transitive. And we can show that on our graph there by basically saying org.joda_beans is adding in an extra link into our module graph. But it turns out org.joda_convert has an optional dependency. If Guava exists at runtime, it will adapt. So it's basically like a reflection check. It says, if I can load Guava, then I will run some code. And we can express that in the module system as well. So basically we can say requires static, bit of an odd word, static, but there you go. Requires static, Google common. And we can show that on our diagram there. So basically, a light little dashed line there from convert down to common. So if Google common is present, then org.joda_convert can use it. So yeah, when we start up, we've got this set of modules. You start from one root module. You can potentially start from more than one. And you resolve a graph. So you start from your root and you basically say, well, that requires this and this, and those require this, this, and this, and this, and then you trace it down. And while you're doing that trace down, you can ensure that all those modules actually exist. They only exist once on the module path, not more than once. It ensures that there's no cycles in that. And it also ensures that the same package does not occur in two modules. Well, that's an interesting one. You can't have the same package in two modules. Well, perhaps understandable. The whole point of this is to have modules isolated from other modules. If you have packages shared between them, then you have a sort of side channel. So it's not allowed. You have to make sure that a module totally contains a set of packages and there's no overlap on those packages. Now, okay, so we've got our module path, but where did it come from? Well, creating a coherent module path, that's your problem. Now, that's no different to today. You have to create a coherent class path in Java 8. You have to create a class path that makes sense, where all the versions of all the dependencies make sense together. It's exactly the same in the module world. You've still got to make sure that all the versions of all the modules make sense together, that they are coherent. That's the point, that versions and selecting them is not part of the module system. And that's really what Maven Gradle should be doing. Now, as I say there, does that achieve reliable configuration? Well, maybe. You know a bit more than you did before, but you're not locking down that my module depends on this precise version of another module. Now, as well as being able to say that I require on a particular dependency, there's a concept of services. So when you need an SQL driver, you're depending on a service. So I want the service of an SQL driver, and then something has to provide the DB2 one, or the Oracle one, or the MySQL one. The same way as I want to depend on the service of an XML parser, and then something provides the implementation of XML parser. So again, this can go into the module info. And what you can say is, that I provide the service of XML parser with this implementation, my XML parser. And then somewhere else I can say, my module uses the service XML parser without actually specifying which precise XML parser it needs. Now, you probably haven't really come across service loader much before, but you may well do in the future. Little warning. So if you're writing a jar file and you want it to be able to run on both the class path and on the module path, you will have to specify your services twice. You'll have to specify them once in a file called metainf/services under there. That's the old-fashioned way of doing it. And then you have to specify it in modulinfo.java as well. So you have to specify it twice and make sure they're both the same. Get that wrong and it won't run on the class path or won't run on the module path. What fun. Okay, so as we said before, we can hide packages. We can completely hide the internal package. So here's our graph again. We've got all our various packages on there in dark blue, and then we've got our import package on the right, which we want to be hidden. So only if a package is exported within modulinfo.java is it going to be visible to other modules. So all the other packages, they are private to that module. Therefore, public does not mean public. You can write a class, you can put the methods on there or the fields on there, declare them as public, but if that class is not in an exported module, it's not in a package that is exported, it can't be used. So you can only see and use that code if it is public, if the package is exported, and the package is readable from the module which you're intending to use it. This combination is accessibility. So that's the sort of diagram again. You have to be able to read down one black arrow, and the package has to be dark blue, and the class has to be public in order to be able to use it. It's like a triple lock, effectively. Here's some things that you can't do. So the rules of what we set up mean that com.opengamma.util can't see public methods in import, nor can google.common. And org.jdebeans can't see up the list. You can't go up, because that's not the arrow, it's an arrow. You can only go down the arrow. And it's the JVM preventing this, in exactly the same way as you can't call a private method from outside the package or outside the class. It's the JVM enforcing these module rules. So it's deep inside the JVM these rules are being enforced. Sometimes those rules might be a bit tough, so there's another backdoor. So you can basically say, when you're exporting a package, you can say, well, I need my friend to have some access. So my org.jdebeans.import, maybe I have in some other module org.joda.special and I need some nice private little backdoor access. Well, I can. But usually that's a bad idea. But remember, this ability to lock down packages is really powerful, but it only works on the module path. If you're running in an EE app server, it's irrelevant. You may have put in all these nice rules, but they're going to be ignored. Now, you could, it is perfectly possible, to write a little bit of logic in a static initializer that basically says, if I'm not running as a module, then end, system exit. It's paranoid, but obviously not much use if you're going to run on your library on an app server. Okay, reflection. So reflection is a really powerful method for accessing code, and it's probably been one of the core things that has made Java successful. Because it's not just, reflection by default allows you to access public methods and public classes and public fields on other packages. But it turns out there's a nice method called setAccessible that basically allows you to break that in, take a big hammer, and say, smash that private scope or smash that package scope. I want to be able to use it. And that has always been vital to frameworks. So if you're Spring or whatever and you just declare some private fields and Spring can magically populate them, well, it's using reflection and setAccessible to get in there. Doesn't play very well with modules, though. So in Java 9, you can access the public elements of exported packages that you can read in exactly the same way as we've just discussed. But you can't access the package scope things, the private scope things. You can't access non-exported packages, and set accessible does not work. That's quite a big deal. It may not affect you directly unless you're a framework writer, but if you are a framework writer, it can be a bit of a pain. What you can do is selectively allow reflection to break in. So at the bottom here, I've got opens org.joda.beans.impl. So basically what I'm saying is that this package, joda-beans-impl, I want it to be private. I want it to be hidden, but I don't mind if reflection can access it. Now, you can imagine that's quite a useful thing as we're perhaps migrating into modules, that basically you might have to allow lots of your packages to be open for reflection, because currently that's how the tools work. So in fact, you can say, my entire module is open for reflection by declaring it an open module. But the JDK itself, remember, is fully modular, and the JDK does not declare its packages to be open, and it does not declare its modules to be open. Ergo, you cannot reflect on non-public things in the JDK. Now, there are frameworks out there that do that. Those frameworks will not work in the same way, and it's up to the maintainers of those frameworks to figure out some alternative way of working. Now, of course, that is a big security boost. Today, I could write a nice little bit of code that basically does some reflection on java.lang.string, an immutable class, and basically changes the array inside string, and messes up all sorts of pieces of code. It is a big boost, but it will break libraries. If it's a problem, there are flags to solve it. Unsurprisingly, module, being a JVM concept, is also exposed in reflection. So there is a class called module, and there's a getModule method, and there's also a module layer concept, which allows you to group modules together and create modules. Reflection has been extended. So taking some existing code and migrating it. Well, as I might have hinted, effectively, as a result of all these rules and things, it does actually turn out to be quite tricky. And I have spent far too many hours and days and weeks trying to make the migration happen for just my open source libraries. Now, partly that's a tricky problem because I want to have an open source library that runs on Java 8, but also contains the module info for Java 9. In fact, I want to have a library that runs on Java 6 and contains the module info for Java 9. And making, the fact that you're trying to set up two different versions of Java and have them run together in one jar file, that turns out to be quite tricky. But some of the things you might run across, logging frameworks, how do SLF for J and log for J and all these commons logging work together? Well, they all stamp on top of each other's packages. That's the way those jar files actually work and operate. But clashing packages, that involves an agreement in terms of what the module name is going to be going forward. So there's still work to be done in that area. Reflection, does that still work in your use case? Some of the alternatives aren't always quite as performant. The service loader, we talked about that earlier, where you have to have your services declared twice. And resources. So we haven't really talked about resources, but files other than Java class files that are within a jar file, those are also encapsulated so you can't see them. So it turns out that if your resource is in a folder which is a valid package name, then it is encapsulated and hidden. But if it is not a valid package name, then it is not encapsulated and not hidden. So, for example, on some of my libraries, I'm going to have to move some of my resources from being in org.joda.beans to being in meta-inf org.joda.beans, because meta-inf is not a valid package name, whereas org.jdebeans is. And I want people to be able to see these resources. Lots of little tricky things that you may well come across. So the theory is, most existing code will just run on the Java 9 class path, i.e. if you ignore modules, you will just run. Now, it depends on the libraries you depend on. If the libraries you depend on have done something naughty, have broken into the JDK, don't work properly, that is where you'll cause your problems. There are command line flags. So you can add exports, you can add opens, you can say, let's break through the illegal access rules. Yeah? And if you use Corba on Java 9, you can add the module Corba. Of course, you can't do that on 11 because it's gone completely. But if you want to run it on 9, you can. In terms of actually running, how does it work? Well, it actually turns out that under the JVM, everything is in a module. It's just that there's a special kind of module called the unnamed module, and the unnamed module is basically all the old stuff on the class path. So that's how it's actually implemented behind the scenes. So the unnamed module, in terms of our nice big diagram, the unnamed module basically has arrows pointing at absolutely every other module. So it can read every other module, which is what you'd expect. The class path can read everything, therefore the unnamed module can read everything, i.e. you don't notice the difference. You'll get a warning if you try and access a non-exported package. It was going to be preventing you accessing it at all, but it's only a warning. And that's why, in theory, if you're in that unnamed module, aka the class path, in theory, you should be fine. But named modules, they can't see the unnamed module. So if you write a named module and you're running it as a named module on the module path, you should just be fine. So there's our class path with a couple of jar files, but it's actually running as a module, the unnamed module, and it's depending on the java.se module. In our case here, it's also depending on a couple of other modules which are correctly structured and on the module path. So the key point here being you can split your application half on the class path and half on the module path, which in theory allows you to migrate things slowly from the class path to the module path. And there's one additional concept, which is automatic modules. So what happens if you take a jar file that does not contain moduleinfo.class and you put it on the module path? Now, our instinctive reaction might well be, well, it's going to throw an exception, isn't it? I mean, it doesn't contain the module info. It's not a modular jar file. But it turns out that's not the case. You can, in fact, put any old jar file on the module path. And if it's not modular, if there's no moduleinfo.class, the JDK, JVM, will make up a moduleinfo.class for you. Okay. That moduleinfo.class has certain special properties. It reads all other modules, including the unnamed module, i.e. including the class path. So we've got a jar file sitting on the module path, which has an arrow up out of the module path, up to the class path. An interesting escape route. So the theory is obviously that you can handle libraries that are not modularized. So the basic theory behind this was that you could take your application with its 20 jar files, which currently sits on the class path, and you could just try putting all of that on the module path, and maybe it'll just work. Maybe. Right. Anyway, there's our nice pretty picture. So yes, we've got down there, instead of org.joda convert being a module, in this particular example on there, it's an automatic module, i.e. it's just a jar file without module info in it. And as a result of being an automatic module, there are arrows out of it going up to org.jodabeans and going up to the unnamed module. So it can break out and it can see other things. Naming. I always love talking about naming. The way I think you can think of this is, a module is a set of packages. What's the minimum size of a practical set in this case? Well, it's size 1. So if I've got a package called org.jodaconvert, and another package called org.jodaconvert foo, the obvious module name for each of those two things, if they were separate, is just the same as the package name. Right? So if I've got a module which contains more than one package, then it still should be named after the package name. It should just be named after the root package name within that. So the example on the board, we've got 3 packages, and the module name should be named after the top of them, the root package org.jodaconvert. That way you're effectively taking ownership of certain part of the module naming space. So if you stick to module names being named directly after package names and the root package names, you'll generally be fine. But what about those automatic modules? Remember I said the JVM JDK is making up the module info for you. That means it has to make up a name for you. How's it going to make up a name? Okay? So there's 2 solutions. The first solution is that within the manifest.mf file, the person who wrote the jar file can say, I want to be called this, please. So when the JDK is making up the name, it doesn't have to make it up. There's one there. You didn't give it a full moduleinfo.class, but you did give it a name. That's a good thing. The other way it can do it is, well, it can take the name of the jar file. So you end up with joda.convert. And those are 2 different names. In case it wasn't clear, good, bad, good, bad. Try to avoid letting the automatic module naming apply. And never ever release a jar file to Maven Central that is depending on something with an automatically generated module name, because you will cause a world of pain to the rest of the universe. So when we use Maven, we have a tree of dependencies. That's what we've always had, right? And IDEs tend to enforce that, but it's never been enforced at runtime. So in all likelihood, every pom.xml in your Maven structure is going to turn into a Java module. Now, in theory, you could try and take your pom.xml and automatically write a modulinfo.java. So you could take your pom.xml, read the things in it, make up the modulinfo.java. I don't think this is wise, because it's like, it's called modulinfo.java for a reason, and we don't normally let tools just write our Java files for us. Right? It's an important piece, it's an important fact about our application, so we should really care what information goes into that Java class. Remember, there's no handling of versions, and it's not selecting particular jar files. So it's another key thing, another key concept. There are effectively these 2 parallel worldviews. So on the left, we've got this build and deploy worldview, where we contain artifacts in our artifact repository. That's jar files that we produce as a result of our continuous integration, continuous deployment. These things are versioned. In Maven, we refer to them under groups and organizations. And as a result, the key, the coordinate to find something, in the case of Maven, would be org.joda as the group, joda-convert as the artifact, 1.2 as the version. And that is a unique key to find a particular thing in our artifact repository. Whereas on the right-hand side is a JVM code view. And that's considering things like modules and packages and types, but it just has the module name, org.jodaconvert. That's the unique key on the right-hand side. So there's a selection process going on here. You can have multiple jar files on the left-hand side, multiple artifacts, 1.0, 1.1, 1.2, or a patched version, so multiple different jar files, which all refer to the same module name. And it is up to your build tool, it's up to your something to select it, to make it, to correctly pick which actual artifact you want to fulfill the module name requirement. Briefly mention OSGI. It's another module system that's existed for many years. It does still work on Java 9, but on the class path, and it's not really likely to work with the module path. It has a whole different set of criteria, a whole different set of goals. It's basically the two kind of exist together. It's not really, they're not going to interact in any future world. So summarizing it, this is a new JVM concept. So it's all about the JVM and that enforcing rules, right? And moving to modules is, in my experience, non-trivial. The reflection changes might influence you in terms of compiled line flags until your libraries have been upgraded, parts of the JDK being removed, reflection being restricted. So there's no real need to rush to modularize. Right? And remember, you don't get benefits unless you actually run on the module path. So if you're a library writer, like I am, it actually means that I now have to write my library and I have to test it on both the module path and on the class path. So my work's kind of doubled. It's not necessarily great for me. There's the link to Project Jigsaw. It does still apply. Obviously, Java 10 is now the current version. Java 9 is obsolete. When it comes to September, Java 10 will be obsolete and Java 11 will be out. Make sure you can upgrade as soon as the new version comes out. Otherwise, don't start adopting these versions. That's my Twitter handle, and I work for OpenGamma. Thank you. We are in luck. I do have some time left for questions if there are any questions. Yes?
I didn't really get the rationale behind not supporting versioning in the module info.java, because saying, well, this job is up to Maven or Gradle, it feels like it's promoting redundancy. Now I have to specify my dependencies in my module info.java and in my pom.xml, whereas if this wasn't the case, conceptually, I could remove those dependencies from my pom.xml and Maven could just infer them from my module info.java.
So the question around is why aren't versions in module info.java? And the reality is that this project went through many different incarnations. And one of the incarnations at one point in its life was it had a whole version system and a whole way of defining versions. And ultimately, it was decided that, we need to have some form of module system out there in the end that actually works and is vaguely sensible. Dropping modules was a key way to actually making that work. So I don't think what's there is crazy. We have artifacts already. We have Maven already. We already have systems for selecting individual versions of jar files. That already is in existence. So there is a separation. If you can keep those two world views in mind, it does hang together. Yeah. Any more questions? Okay, I've got one here. Yeah.
Did it change anything for class loaders?
Has it changed anything for class loaders? Yes. I believe that URL class loader is not quite the same anymore. You'd have to drill down into more details. I can't tell you the details as to exactly what's happened to all the class loaders. But yes, class loaders have changed necessarily as a result of the boundaries being different. Yep, in the back.
Does this mean that you can't have module info class in your jar file and run it and all the versions of Java?
So the question is, can you have a module info.class file in your jar file and run it on older versions of Java? Well, you can. As I said, I'm producing a library which is for Java 8, but also contains a module info.class file for Java 9. It works, and it's absolutely fine, until you come across some old bytecode library that trawls through the jar file and loads every single class file in the jar file and finds module-info.class and goes, help, I don't know what to do with this. And as a result, not only have I had to have test on module path and class path, I've also had to produce a -classic jar file for those old projects that can't cope. Happy days. Yeah.
Out of curiosity, how many of these projects have you found this classic, in need of classic?
So the question is,
Rare, or are they...
how many projects are going to need a classic jar file? Well, the reality is, as it stands today, if you run Tomcat 6 or something, right, it will contain a bytecode library that will check every single .class file, and therefore you cannot have a jar file with module-info.class running on that app server as it stands. Therefore, the only solution to that at present is to create a -classic.jar file. Oh, and by the way, Android can't cope with module-info.class either. So if you're running on Android, you have the same problem. One would have thought Android was a big enough project. It could just do like a excludes module-info.class when they do their work, but apparently not. Yeah.
So it's quite a big problem.
Any more? Here we go.
So with the removal of Java XML annotation library, a lot of people were using the annotations, for instance, in JSR 305 with abnullable, together with annotations like generated, which is Swagger, for instance, uses. So you got packages that have the same name. Are you just saying we need to be patient and wait for them to come up with one common job?
Yeah, so the question is around XML libraries and annotations that have disappeared, in effect. And yes, essentially, the theory is that if you wait a bit, other jar files, other modular jar files will appear from Java EE, or should I call that Jakarta EE, or that they will produce new jar files that will be have new module names and will contain the right things. The @generated annotation has in fact moved to somewhere else. It was meant to move to Java lang annotation, but at the last minute they moved it to some other weird location, which I objected to, but didn't succeed in my objection. So @generated I don't think is actually terribly useful anymore. But there you go. Yeah, it's going to take a while, for all these things to flow through the system. Adopting JPMS now is really hard. Trying to write module-info.java files now is really hard because you'll find most of your dependencies won't be modularized. The best thing you can do at the moment is just to put in, reserve your module name. In that manifest.mf file, just put in your automatic -module -name, reserve your module name, and don't worry about the rest for a few years. I think my time is up, so thank you very much.